Hello, thank you for joining us. My name is Nicholas Mulder. I'm an application engineer for the EMEA market. And today I would like to talk to you about the advancements on FTTx networks and what are the next steps to provide service to even more people. So before that, I would like to contextualize a little bit about the technology and how we reached the stage that we are today. So FTTx networks started in around the year 1999. We had Japan as one of the first countries to deploy FTTx in a mass deployment, and following a lot of the countries in Asia also started doing it. So since then, FTTx became very popular, and now we have more than 35% of the homes in the world with fiber connectivity. I know 35% might not seem like a lot, but we're talking about more than 800 million households. So this is all around the globe. So what were the drivers to get this technology to where it is today? So first of all, when the deployment started, people were looking to alternatives to provide high bandwidth. So carriers looked at fiber as a great alternative to provide this high bandwidth to customers. Going on, although fiber is still and was very expensive and required a lot of skilled labor, in comparison of the total investments that were made to create copper networks, fiber could present itself as a cheaper alternative for carriers. Besides that, it enabled multi-service networks, so they will be able to provide a landline, internet, and also service for TV and entertainment. So all of that started to really catch the carrier's eyes, and FTTX started to become way more popular. So with all of these advantages, the technology itself with fiber is also future ready. So people took into advantages all of these and started to mass deploy this. But when you look at it, we still have a lot of places that do not have as many users as some places in the world. We have countries with more than 95% of household penetrations, but also we have countries where we have like 10%, 2% numbers that were very small. So looking into the sub-Saharan countries, what we have is that we have currently around 6.5 million subscribers. This is data from the World Bank for fixed broadband. So looking into this number, what we have is this accounts for around 2.2, 2.5% of the whole availability of households in here. So this is not a lot. Then when we look specifically into FTTH and FTTB, what we're talking about is that with this whole number of households in the whole sub-Saharan region, we only have 1.1% up to 1.5%, which is a very small number. So why we have such a small number? So first of all, it is very related to the deployment of fiber. So when we start deploying fiber, the first places to get it are the urban areas where you have a high density of users, where you have a penetration rate that is more certain, and also you look into where you can get your investment back faster. So we went to the prime real estate areas. So luxury estate, buildings, everything that you can guarantee that installing that network, you will get your money back. Besides that, we also have infrastructure available. So we have ducts, we have poles, we have facade installations, and all of that makes the fiber deployment less costly and easier. Another point to take into consideration is also the labor. So in urban areas, we have more labor. It is easier to find skilled people to perform the installation. But then, as fiber advances, we are reaching a point where all of the prime real estate areas, all of the areas that have a more certain penetration rate, are already occupied by networks. and then we need to move into new areas. And this is the other 98% of the population that we're talking about in some countries. Well, in these narrow areas, we have challenges. So there's a lot of lack of infrastructure. So there are no ducts, there are no poles. So this will require more construction work. You have lower income households where the penetration rate is uncertain. And also you go to suburbs and countryside where things are further away. So it is harder to find skilled labor. It is harder to find uh, personnel to perform the installation. So with these new challenges, becomes very difficult for operators to advance using the same type of construction and the same type of installation that they were used to do, where we had a lot of splices, where we had a lot of fibers with high count, and everything was very labor dependent. So the challenges now are how to keep up with the increase in demand. So we all seeing that people are craving for more and more bandwidth, and also how to reduce the complexity to build it. We're going to areas that don't have infrastructure. We're going to areas that cannot wait for trenching and placing ducts and to perform this installation. And then for carriers are areas with uncertain penetration rate. And even after the installation, what we have is that we need to maintain this network. And how to go with that? Well, once again, it is time to change a little bit how we construct to a new type of installation. So we're moving from a very artisanal, very costly and difficult deployment to a more to a more optimized with pre-terminated technologies with new use of splitter balancing. So we need to work in each and every aspect of the network to reach optimized construction and then to have access to these areas. So we're looking into a high performance network that has low maintenance and is very flexible in terms of construction, so you can reach the right areas at the right time. So when we look at the network itself and the build, what we want, it is a fast installation time. So we try to reduce the number of splicing. We try to reduce the type of infrastructure. So going to aerial deployment with poles, going to facade deployments. We try to have cables with less fiber to cause less disruption. And you try to create teams that are easier to train and easier to replace as we have a high turnover rate in this type of work. So also, we want to operate this network, provide maintenance, and expand on the future. So we need to generate a network that is easy to maintain. So we're looking into products that can be easily removed and replaced. Then the repair needs to be very easy. You don't need to have a very specialized team to perform splices and everything. You just need to put the network to work again, ensuring the quality of service that you will provide to your users. And also, you need to maintain the cost level down because, as mentioned, we're looking into uncertain penetrate rates. You need to guarantee that the investment made on building the networks will get back to you. And all of that can be really affected by training. So you reduce the number of specialized labor needed. You contour the high turnover levels of users. And also you can have supply support to train and perform live videos and accommodate other needs that may appear during the installation. So that's kind of what we're looking at with the EasyStar and EasyGrow solution. So we took those challenges, and those challenges arise in different countries all over the years as the maturity of the FTTH networks grew. So once a country passed a certain percentage of house passed, we got into a level where carriers started looking to smarter ways and faster ways to deploy. And this is how we reach this type of technology. that is using fully pre-terminated products to decrease the complexity of the installation, also to enable a flexibility using unbalanced splitters, using sealed boxes. So you can install the boxes on demand and also on a design that is easier to flexibilize and reach more and more users. So here, for example, what we're talking from a traditional perspective, you would have a splice closure where you would have many splices. But on this case, we're talking about one splice. And from this one splice, we're using a single fiber cable to reach sealed boxes. So it is a completely plug and play system for the installer to provide service to users. So as we can see, we move from more than 64 splices to only one splice. So we start to gain momentum and we start to decrease the complexity of the installation. So we took into consideration some of the previous projects that we did in many countries. And we have that usually when we're talking about a traditional installation, we need specialized labor. It is a team from 5 to 6 technicians, and they will have to use heavy reels, use special tools just to get to the pole to perform the installation. And this takes a lot of time. When we move to a pre-terminated solutions using single fiber cables to interconnect this network, what we have is that you can have labor that is not as specialized, that knows how to operate a splice machine, that it is depending on the weather, the conditions, the materials that the customer is installing, because everything is pre-tested from factory. And then we saw that they were able to perform the same interconnection with half of the team, because the cables are very light, they're single fiber cables. And as we can see here, the technicians can basically install by himself this cable. So it is a very fast installation. So what we see is 50% less technicians on the team and up to 150% faster installation with the pre-terminated solution. And when you have that, what you do is that you can put these other installers, or that meaning half of the team, to install in other areas. So this way you can reach more and more users in a faster pace. And as the uncertain penetration rate that we have in these new areas, the first carriers to get there is the one that takes advantages and really gathers the users. Also, on the activation process and the installation, usually when we have an access box to provide service to the users, we're talking about a box that needs to be spliced, that the installer needs to open to perform the activation as the user, and also it needs to fixate and have all a management system to be sure that the signal will reach the customer home. And a lot of times when installing one customer, what happens is that a disturbance on the customer right next to it, because maybe the technician performed splicing correctly, maybe it moved the fiber from other customer. And all of that creates the necessity for maintenance. So every time that you have a maintenance, you need to get someone from a team, go up there and solve the problem. And with that, customers start to get angrier and angrier and angrier. So with a pre-terminated solution, we're talking about a box that is fully sealed. So the idea is just fix it on the pole, use fully pre-terminated cables, and then you're ready to activate. So here, with less specialized labor, you basically need to plug connectors. So you will have all the accessories ready to go, and you will have the performance that is guaranteed from factory. So you can have an installation that is way cheaper than a traditional over time. So here, an example of what this network will look like. So this network is going from a network that would have 24 fiber cables, 48 fiber cables all over it, to a network that is fully interconnected with one fiber cable. And the advantage of that is not only on the splices, but also on the installation. If you have a lightweight cable, you don't need as many hardware. You don't need a team that is large with many technicians to make this installation. You can have just a small team and you can reach faster. So for example, if you start your network and you only have demand for these houses up here, you can just come and place this first box. After some time, if there is demand on across the street, another place, you can just expand with a plug and play kit and you will be able to provide service to more users. So this is the shift that I was mentioning about, that when we started with prime real estate, when we started with FTTH, we were trenching everything, splicing everything. Everything needed to be very well done by the technician, very dependent on the labor, very dependent on the quality of the material being used and the hardware and accessories. And now we're looking into a technology that is easier to deploy and it is easier to maintain. And that makes that the business for the new area that wants bandwidth, wants fiber, becomes more feasible. And this will help us to deploy FTTH past that 1.5% that we currently have in sub-Saharan Africa. So here, just to take a look into the products that we're dealing with, we're moving from a traditional box, so a first box that will enable splices. Then we're talking about everything from this point on with pre-terminated connectors. And the idea is to have products that are fitted for each and every installation. So these boxes can come from a pole installation to an underground installation to a facade installation using the same product. Because we know it is also important to maintain stock and don't have many different of products when performing an installation to ensure that you have the material. And then we're talking about the use of hardened connectors. So these are connectors that are fully manufactured in a factory. So they are tested, they are connectorized, they are not labor dependent on the field. This guarantees that your network will not only be easy to install, but will have a high performance. Because when we talked on the beginning about fiber network, we said that, oh, it's future-proof. But it is only future-proof if it is done right. So if you have a bad installation from the start with high losses on the splices, with bad accommodation of cables, with bad connectors, this network will not last long, because as technology evolves, it might require more and more quality of the network, especially over the years. So the idea is to provide a connector that is fully assembled on the factory, and then that the workers will only have to plug this connector into the boxes. So what we have here is a IP68 connector. And as mentioned before, using smaller cables also means smaller hardware. So we move from those big hardwares that are heavy and expensive to simple anchoring devices as plastic clamps like this one that will also secure the cables, but maintaining quality of the installation itself. Then we move to the really fun part in my point of view, which is the sealed boxes. As mentioned before, talking about a traditional network access point, a box that will connect the network to the end user, you would usually have to open that box, maneuver the fibers, have access to the connectors, and every time that you would have to activate a user or install a box, you will have to perform some type of action inside of it. And more you mess with it, bigger is the chance that you'll have some sort of problem. And here we created a fully sealed box. And the idea is for the technician not to touch anything inside, just connect the cable and have access to the user without any problem. So as we can see here, it is a very compact box. So once again, you can install it on poles, we can install it underground, and you can also install it in facade. And to install this box, it's fairly quick because one fiber cable connects to the box. The box inside of it has splitters, has everything that it needs to have without any type of intervention from the technician. And that point on, you're ready to activate all of your customers. So this is also a big improvement on the deployment, not only in time, but also on the quality, and then how to maintain the network further the line. And we know that sometimes problems arise not from the product itself, but something that happens. For example, car accident on the pole that took the box, something that disturbed the network. But here, it's much easier to replace this box. If we were talking about a traditional box, you would have to get a new box, pass a new cable with multi-fiber, open that box, perform all the splices, put the splitter on, connect, and then replace each and every connection to the subscriber. Here we're talking about a product that is fully assembled. You will just fix on the pole, get with one fiber connector here on the outside, and then you are ready to provide service to your customers. So the repair time, it's way faster. And this way you ensure that the customer is satisfied with your service and will keep using your service for longer. So once again, we talked about the connector, and this is the connector for the interconnection cables and also for the activation cables. We're talking about connections with typical insertion loss of 0.15 dB. They are very robust, IP68, ready to install, and very easy to maneuver. So as mentioned before, this technology is not something completely new. It is something that has been deployed in many countries, and we've seen how it works and how it can enhance the technology. So for example, in Latin America, we have in Brazil, Vivo, which is from Telefonica Group, that deployed a lot of these boxes and pre-terminated accessories to perform connections, and they were able to reach more users over time thanks to that. And the same case for Easy in Mexico, where they had this massive challenge that was to deploy over 1,600,000 house passes in 2 years. And actually, they were thinking about even a longer time. But with this pre-terminated connection, taking advantage of the use of the splitters and everything, this became something that was way faster and allowed us to reach that level of connectivity in less time, actually. So what I would like to keep from this talk is to start thinking about the new challenges, the new scenarios that we are facing, and how we need to change the way we construct network to be able to reach each and every user in our network, in our country. So I would like to invite you to contact us through email to understand a little bit more. If you have questions, please add me on LinkedIn as well. So I hope you guys enjoyed our brief discussion about FTTx networks and the changes that we have. And I hope you get a little bit of insight of these new technologies that are coming and these new ways to install network to apply to your scenario so we can connect even more people. So thank you very much for joining. I hope to see you next time. And please feel free to email me if you have any questions.